Thank you, Joe, for inviting me here to talk. I'm delighted to be here to talk about some of the really exciting programs that we've developed at UNH to help to implement the cognitive principles of learning right in the classroom. And I'm happy to share with you 3 of the studies that we'll be covering today. Before I begin, though, I would like to give thanks to the Davis Educational Foundation, who have funded us for about a decade in cognitive science of learning application in the classroom. They fund this kind of thing. I'd also like to thank the university for their support in our endeavors, and especially I'd like to thank the faculty and the students who have participated and produced some of the quite wonderful results that we're about to see in these 3 studies and in dozens of other studies that we've done across the university. So just to outline some 3 broad goals of education, we want our students to learn. Primarily, we want them to learn. And then, once they learn it, we want to make sure that they retain that information. And hopefully, they'll ultimately be able to transfer the information into new and novel situations. So stepping back, those are the 3 aims that we hope to achieve when we have our students come into our classrooms. There's a basic principle, though, that students undertake as they go into their classes. If you ask students simply, if you had a choice of a method to prepare for an exam, the majority of students, in fact 80% of students that we've interviewed, will report that they would rather reread or restudy the material than to quiz themselves. And what we know is that, and students probably don't know, is that whenever students are quizzing themselves, that they do tend to learn better. And we've shown this in dozens of studies throughout the university as well as in empirical science. What I want to talk about today are methods to introduce desirable difficulties in the classroom, and a little bit of background is that we know that desirable difficulties are learning activities that are especially designed to create and to challenge learners in some way throughout their study. These activities are likely to produce errors, and students, if you ask them about their studying, anything that is challenging for them and that does produce errors, they tend to think that those kinds of strategies are not as effective as other kinds of strategies in which they don't produce errors, such as rereading the text. Students get a feeling of knowing when they reread the text, and they think, oh, okay, well, this is easy. I remember reading this. Yes, I know it. Whereas if they are quizzed, then they tend to think that, oh, I made a mistake there, I didn't learn it as much, this is really hard, I don't like this strategy at all. And they tend to not want to engage in those kinds of strategies. The issue is that whenever they do engage in these challenging strategies, these challenging learning strategies, that it is shown to produce more enduring learning over time. So how do we introduce desirable difficulties in the classroom? Well, we can think of it in informal ways and formal ways that we can do it. One thing that we can do is during our lecture, we can introduce some questions along the way. So we provide some information, ask questions, have students raise their hand, answer. That's a way that we can get them to kind of process the information and produce an answer. We can do it through questions and clicker questions, through any number of ways that are informal in the classroom. When we think about the formal ways of introducing questions, think about maybe low stakes grading. And again, you can apply all of the informal ones to make them more formal by adding some low stakes opportunities there. What we found in implementing our strategies in the classroom in the dozens of experiments that we've done throughout the university is that when teachers present these strategies, these interventions in the classroom, and they make them voluntary for the students to do it because they don't want to have they don't want to feel like they're in control of their students, and they want to give their students choices of whether or not they want to do them. We find that there's lower compliance in the students in completing the activities, and also the students who tend to need it the most tend to be the ones who don't cooperate, and we lose all that very important data. So whenever we're consulting with faculty, we always advise them to try to make these interventions have some kind of stakes to them, apart from just a bonus point on an exam. We ask them to make it a homework assignment or do something for having completed the item. I do, again, want to talk about our book that is freely downloadable. Thank you, Joe, for mentioning it. And Clark and Bjork have written a wonderful chapter on desirable difficulties in there. I encourage you to get this and read it. You can get it from the STP website. We think it's excellent. So a little bit about retrieval-based learning, a little primer, if you will, also known by these terms and others as well. And what we know is that when compared to restudying material, that is oftentimes rereading according to the students, that's what they choose to do. Whenever information is quizzed, there is better learning outcomes for that material that was quizzed than material that is reread. And why this works, there are two general mechanisms, broadly speaking. First of all, what it does is it promotes learning by helping students to understand and what they don't know, and it helps to guide future study for them. It also acts as a formative practice for teachers. They can review the quizzes, they can find out what the students don't know, and they can review the information. And so it acts in that kind of indirect way, but it also acts in a more direct way by active retrieval practice. So that's just an overview, a broad overview of retrieval practice. And the three studies I'm going to go over with you today all use a form of retrieval practice as a base. And what I'm going to do is show you three widely different ways and three widely different courses in which we incorporated these strategies. The first one is a clicker study, also using retrieval practice during the class by clicker use. The second one is a spacing study, spacing versus massing, and the third one is interleaving of practice. So quizzing, test-enhanced learning, and in this instance it's going to be the clicker study. And what we do, generally speaking, at the University of New Hampshire is whenever we're interested in a topic, we take a semester or so, we put out a call to faculty throughout the university. We say we're going to be working on these particular projects. If you're interested in applying them in your classroom or learning more about it, please come and see us. We'll be happy to work with you. They come into the office, we have a little interview about their class as a general topic. We look at what their enrollment is, how they typically present the material, what kinds of assessments they use, and so forth. And in this particular case, we asked about their clicking practices. And the one that I'm going to present today was Adam St. Jean, who is a chemical engineer, and he had this class in energy and the environment, and it was made up of undergraduate students, about the freshman level, generally speaking. There were about 250 or so students in the class, which for us at UNH is a large class. And we got about 99 participants out of that. These are the people who completed the entire process of the clicking project. And so I asked him, why were you interested in undergoing this project? He said, I'm just really interested in clicking and what you have to say about it, and I'd like to make it better somehow. Other teachers would say, well, you know, I don't really know how to use clickers. I use them for attendance, or I use them for survey purposes or whatever. And this particular teacher wanted to know just how he could enhance his use of clicker. And what we wanted to know was, does clicking itself make a difference? What was it about the act of clicking that makes it work, beyond the fact that most students seem to like it? If you ask students in a survey, did they like the clicking experience, they'll typically say yes. They liked it. But we wanted to know about the actual process or the paradigm that Eric Mazur used and that he publicized about the clicking, and we wanted to know what was it about his process that made it work. This is his general procedure. He presents some information, he asks a related question on that material, and then he had students think about it for about 30 seconds. He has them then click on their response, and then he has them discuss it with a peer. Ideally, what he wants them to do is find a peer that has the opposite response, try to argue your point with the peer, and then he has them click again and see what the results are, and he provides, I believe, some feedback at the end. Now, we were really interested, what was it about this process that makes it work? Is it the actual clicking? Is it the active thinking? Or is it discussion? Is it peer discussion? Or is it a combination of all of these things? We weren't really sure, and so we decided to explore this. And we did this by our protocol that we had. With Adam, we asked him to every single day create 5 objectives for that day's lecture. And on each objective, we had him to ask a question. He wrote those questions, sent them to me, and then I randomly decided which 3 of those questions were going to be asked in class. The other 2 were going to be control questions that the students never saw. So what he did was he presented the class material. He then asked a question in one of the 3 presentation formats that I'll share with you in a minute. And then he provides feedback. So about the presentation formats, we arrange them in order so that we can kind of deconstruct the elements of Eric Mazur's strategy. And so here they are. One of them is, I need to read closely, is click, discuss, click. And that is that he would present the material and he would have the students click their answer, discuss with a peer, and then click again. In this case, the formal thinking is removed. And so he didn't have them spend the time and think about it. Okay, click, discuss, click. Now, one thing about this study 1 is that he presented all of the strategies, he presented a single strategy on a day. And so if today was Tuesday, he would present all of his 3 questions using that strategy. On the next day, it was click, think, click. In this case, discussion is removed. And so what we're doing is we're parsing out each piece, each component of the presentation one at a time. So this would be another day. And the 3rd day is think, discuss, think. In this case, the clicking is removed. And so what we did is as I said, we parsed out each component. We also had a series of questions that were hidden. Students never saw them, but a representative of those questions was presented on the exam to use as a control. And so we had him then take each one of those questions, except for the ones that the students didn't see, because there's no need to transfer those questions. That was an example of a clicker question that he used in class, and then a transfer question on the exam would look like that. And typically the transfer questions were applied questions. You don't have to worry about that. I'm not going to test you on that later. So what were the results? So as you can see, I have each of the presentation strategies down below. And on the left-hand side are the mean % correct on the exam of transfer questions. And these are the questions that were not asked. Students never saw these questions. And you can see the % right that they got on those questions. The discuss click condition, this is how many they got right, and you can see that there is a testing effect there. They did get that question, a transfer question on that original question. They did well on that. So we were pleased to see that we got that testing effect. And then we have the condition, which is click, think, click, which again shows a testing effect. We're pleased by that. We were most surprised, however, by the final condition, which the clicking was removed. And so we're wondering, wow, this is really strange. We totally did not expect this at all. I thought they would all be sort of versions of the testing effect around the same level. And we got this odd result. We're very, very surprised. And so we decided that, well, maybe because the strategies were distributed over days, maybe what it was a result of just selection bias, so that the day that we randomly assigned a strategy to a particular day might have been that those days were just easier material, and maybe that's what it was. And so we devised a study 2 where each day there was a variety of presentation styles, so that the styles were within the day, the class day. And so we eliminated the control at this point because we know we're going to get a testing effect. So we just eliminated the control. We looked at the 3 strategies of clicker presentations. And there you have it. And so that's how we ran study 2. And we were really curious to see what we'd find here in terms of the clicking. And so here we have the results. Midterm exam, again, there are 3 strategies. And we see a little higher distribution in this class. As you know, different classes will have different abilities to them. But we see the same 2 involving clickers around the same correct responses. And then again, we see the elevated response for the thinking condition where the clicking is removed, just the thinking and the discussion. And there is, by the way, that is a significant difference between that and the other 2. And so we were very interested in that. So I'm not saying throw your clickers away, but I am saying that if you don't have clickers, say your class is small and you're not going to invest in clickers, it's not a big deal as long as you ask the question. That's the important thing. All right, so on to the next intervention, and this is spacing, distributed study practice. Let me this over. And we did this in an introductory biology course. Our current grant right now is in STEM retention, and what we're doing is we are implementing cognitive bases of strategies, cognitive strategies into these courses to see if we can improve success in these courses to hopefully improve retention. And we're working with a biology professor here. And her course, there were about over 200 students. In the course, we ended up with 176 who completed the entire protocol. And we were very pleased with this because she did make this a requirement for the course, this particular strategy, and we did get a better compliance rate. And I think we helped the students a little bit better too in the end, which is really the important thing. And so what we did was we did a kind of a replication of Nate Cornell's 2009 study on flashcard study in applied cognitive psychology, and we looked at study 3. I'm going to go over that study with you first so that you can understand what we did. What he did was he used it was a laboratory study. He used GRE type vocabulary word pairs, and he had students study these word pairs on 4 consecutive days in 4 consecutive days, and then he had them do a practice day or a review day, and then he had them quizzed on the material on day 6. And so basically what it is that on study day 1, students got 20 vocabulary words that they had to study, and they each studied them twice. And then he had a masked section where students studied 5 items, yes, and they studied them 8 times each. And so that's the only time they saw the masked items was that one time. They reviewed them 8 times. The 20 items, they reviewed them twice. On day 2, they reviewed the same 20 items twice, and they reviewed a new 5-item block. They reviewed them 8 times, and so forth for 4 days. Okay, so each of the days they got a new 5-item block of vocabulary words. They reviewed each time, 8 times. And so altogether, every term got reviewed 8 times. They then, you can't see it up there, but they then had a review day where they could just review all the items, all 40 items, and then they had a test on all the 40 items. And what he got was this. There was an effect for spacing. Let's see over here, an effect for spacing. The mask conditions were significantly less than the spaced. And so what we wanted to do is we wanted to replicate this in the classroom to see if we could get the same effects. And so in our biology class, there were 176 students who completed the entire 5-day protocol, I guess. And it was a within subjects design, so all the students were exposed to both conditions, both the space condition and the masked conditions. In this case, there were 36 items rather than the 40 that Nate Cornell did. There were 36 items. We asked the teacher to come up with 36 concepts that she wanted the students to know, that they would be expected to know for the exam. He did his on a computerized flashcard program. We didn't have that. We used a quiz platform on Blackboard. And so what we did was we put the questions into Blackboard on the quiz platform. They were all open-ended questions. The other thing that Nate Cornell did, he wanted to replicate how students actually study with flashcards. And so they didn't have to write anything down or document what they did. They just had to think about it. We wanted to go a little step further because we wanted to make sure, first of all, that they did it. So if we just had students look at the flashcards and not document that they did anything, we had no guarantee that they actually did it. So we had them write a small response to the question, and we asked the teachers to, when they asked their question, to make sure that the question wasn't a question that involved a long response, because we didn't want students getting fed up with the whole thing, having to write this 8 times perhaps. And so, but we wanted it to be a short answer, so they did actually have to write something down. These weren't graded in any way. We just wanted to make sure that they did it. The 36 items by us were randomized to a condition, to either spaced or massed. The teacher had nothing to do with it except for come up with the concepts. We did everything else. Spacing or massing, and when they were massed, we also randomized those questions to be day 1, day 2, day 3, or day 4. Students completed these space versus massing practice on each of the consecutive days prior to the exam, similar to Nate Cornell's. We didn't have a special day for study because we assumed that students would be studying anyway along the way, and so we added that as an assumption, if you will, that the students are studying as well as doing these activities. We did an analysis also on how long they took to complete this activity, and they took anywhere from an hour to an hour and a half, which is quite a commitment for students, and to do 4 of these just before the exam. Interesting anecdote here. One of the students, we did this a couple of semesters, and the second semester, the students, so what happens is they take one form of biology one semester, another form the next semester, and then following through, they kind of swap over, so it's the same students. And they were asking, gee, are you going to do that flashcard thing again? Because that really helped me study. So some students actually did like it, which was kind of nice feedback. I suspect that they all didn't like it. Sometimes they said, gee, some of these items we just kept seeing over and over again. What was that all about? Okay, so another way to look at how we did it too is we had 36 total items. The first 16 were spaced, the second 16 were massed. Again, they were all randomized into the condition. And here you have the details here that we reviewed with Nate Cornell's. Just another way of looking how we organized it. Okay, so the results. What we found is an overall effect for spacing. Again, these are transfer questions, usually transfer applied questions based on the original concepts. And students did extremely well in the spaced versus massed conditions. And what we have for the overall day condition is surprisingly familiar. You might think that you've seen this slide before. This is exactly the pattern that Nate Cornell got with his. Really interesting. We were surprised and very delighted to see this happen for us. So, okay. So, the final study that I'm going to talk about is interleaving, and revisiting the past, if you will. And this is done in an introductory statistics course. We actually did 2 studies. One was a replication of the first, and I'll tell you why we did that. 2 experiments. Okay, so interleaving of practice, just to kind of give you a little primer on what that's all about. So if you have concept A, concept B, and concept C to be learned by students. In the blocked practice, what happens is that students will study items related to that one concept over and over and over again. So for instance, if it's a Z-test, then students will be studying the Z-test over and over and over again. They'll do various problems on the Z-test and so forth. And then the next one, maybe that's a t-test. They'll learn all about the t-test, and they'll do practice problems on that and so forth. And then when it comes to another test, they'll just do that. Interleaving of practice is when you take all of the concepts together. So you might take the first 3 statistical tests and do that over and over again, and then you study them randomly within the block. So you're going to study them all, then you're going to study them all again in another way, and then so forth. And so each item gets studied again, but in a different order, and it gets reviewed. So current information with past information and so forth. That's the paradigm that we used for our study here. So basically what we do is we cover the materials. That involves both lecture, both reading material, practice material, and then they are introduced to a module. So once the material and the students have practiced their problems and so forth, they enter into our module, and our module is the interleaving versus no interleaving condition. Behind the scenes, we randomly assign students to be in the either interleaving group or the non-interleaving groups. Students never knew that they were in a group or a study, and that's pretty much how we do our practice, is that students never know. We don't want to influence or bias the results. We tell them in the end what happened, but not as they're going through it. And unless they talk to their roommate, if the roommate had a different condition, maybe they would have a clue, but I don't think they really knew what was going on. So basically what happens with these modules is that they've had the material, now they're looking at it, and they're given a little review about that particular statistical test, about the components of it, about the requirements for it. They're also given an example of a research design, and then another rationale as to why this research design is appropriate for this particular statistical test. After that, they're given a quiz, and the quiz is on the content for both of them. For the non-interleaving group, all of the quiz items, there were 8 of them, were all related to that particular statistical test. For the interleaving group, they got questions related to that particular statistical test and all of the ones that preceded it. Okay, so the statistical tests that we cover are up here in the order that we cover them. And so, for example, in the correlated groups t-test, students in the interleaving group would get questions related to that and questions related to the other ones. And what we wanted to do, our goal here, was to try to improve students' memory, learning and memory, for when to apply a particular test to a given scenario, a given research scenario. One of the issues that we have is that once students do statistics, they then go into research methods class, and the research methods teachers were, perplexed. Why don't these students understand what a t-test is? I don't understand it. They're thinking you're going to do an ANOVA, and this should be a t-test. And so this was a problem for them. And so we're trying to figure out a way that we could help students to be able to understand and to recognize when a particular statistical test is appropriate. So it was a within-course experimental design, but between subjects. So basically you had the same teacher, you had the same learning materials, you had the same classroom environment. The only thing that varied was the condition, okay, interleaving versus non-interleaving. In this first study, there were 44 students here. This particular teacher, who was a graduate student at the time, made he made it voluntary. Okay, it wasn't required, it was voluntary. And so I think the results kind of reflect that in some ways. Even though we got good results, it kind of reflects it in the terms of the overall performance. And so you have the non-interleaving performance. You can see the proportion correct over there, pretty low. And when you get the interleaving, it's better, but the overall performance is still pretty poor because we suspect it was because it was voluntary. So we worked with another graduate student, and we said, please make it required, give them points for it, however you're going to do it, points correct or whatever, just give them credit for doing it, and we're hoping to increase compliance. And so we did the same thing. This is introductory statistics again. Raska was the teacher for this. There were 38 students, and we had the same exact design, and what we got is a little bit better distribution of scores, and this is the non-interleaving group and then the interleaving group, and again we have a statistical significance here we're very pleased about. And so we are working to encourage our teachers of statistics to try to introduce interleaving into their course. That's it. Thank you very much. I think that wrapping this all up, introducing desirable difficulties in terms of the ones I suggested and more that I haven't even presented here are easy to do. It doesn't take much for the teacher to structure the course and to incorporate these activities into the curriculum, and in the end it does help to boost student learning outcomes, hopefully increase success and retention if possible, and so thank you very much, and I guess questions.